Hi, Stefanos.
Hi,
Thank you for participating in the interview of SEANERGY project. On behalf of Protasys, could you please introduce yourself, your role, and the company shortly?
Yeah, sure. So, first of all, I'd like to thank you for participating in the workshop the previous weeks regarding the decarbonization of the ports. I'm Stefanos Dallas. I'm the EU project manager of Protasys SA. Protasys is an engineering and consulting company that delivers expert consulting services and is specialized in system solutions for safe, reliable, and efficient operation of electrical energy networks and installations. We act as a power consultant and system integrator for protection control monitoring system and substation automation systems, as well as smart metering systems on power generation and supply networks. Our company is a key player in the power and energy sector, offering integrated systems, expert studies, and technical consulting services, and ensuring the reliability and safety of electricity generation and supply is top priority for us. And we're deeply committed to promoting environmental sustainability, actively contributing to decarbonization and electrification through smart, efficient, eco-friendly solutions, which align with our corporate culture and strategic development.
Great, thank you very much for this introduction. Protasys has an impressive profile that is one of the reasons that we think it's very important to address you as an important player of the industry sector in Greece regarding port decarbonization. And I will go straight to our first question, which is based on the studies you've carried out so far and your experience so far. Which technologies regarding port decarbonization are the most ripe for installing in ports, and especially Greek ports, I would say, according to your view?
So, can begin by saying that all this effort has become and developed, taking into account the EU's commitments to reduce the emissions by 55% by 2030, the Fit for 55, and subsequently make EU carbon neutral by 2050. So it becomes crucial for all ports to comply with these regulations. Notably, I think that the ports in the Mediterranean is, let's say, a little bit behind this overall progress, since the northern ports in the North Europe have taken significant steps in implementing electrification systems that include shore-side electricity supply and battery chargers for battery ships. Moreover, we can say that there are collaborative efforts to advance hydrogen technology for fueling ships that can be supplied from ports. But despite the global push towards decarbonizing the ports, not all of the above mentioned technologies have reached a maturity level that's suitable for widespread implementation. So at the time being, we can say that the shore-side electricity installations, the cold iron, the so-called cold iron, can emerge as the most mature technology for some reasons, several reasons. First of all these technologies are already in operation. As I have mentioned, they have been installed in a broad area in Northern Europe, but we can say that these technologies have been also implemented in, let's say, the Mediterranean ports, Spain, in France, in Greece. Okay, we can say that Kyllini port, although it was a pilot implementation for small passenger vessels. Moreover, electricity as a maritime fuel is positioned as one of the most environmentally friendly options for the foreseeable future. All the manufacturers of these systems, the OPS systems, they have expressed their confidence in their adequacy, foreseeing an increased demand in the future. Since let's say the deadline for 2030 is not far away, the ports will start demanding more and more of this type of systems. And finally, in this technology, we can live outside the cable management systems. Let's say it's a part of the OPS. It's the system that connects the port to the vessel. And these systems are continually evolve to meet the diverse demands of each vessel and port, contributing to the maturity of these technologies. Especially the last one, the cable management systems can be different for each port and vessel.
Okay. That's clear. Thank you very much. Yes, I think it's something that confirms also what came up from our workshop. In fact, that cold ironing, let's say, is the most ripe technology. And therefore, in this direction, I would like to ask you if you can tell us more about the solutions Protasys is working on, either on application level, implementation level, or on a study level, and specifically in which ports do these solutions apply?
Okay, firstly we can discuss regarding the studies for these OPS systems. Our company has developed several studies for a lot of ports, both national and international, for different type of vessels through set projects, let's say E-Link, Atheon, Cyport, etc. We have performed studies for the port of Piraeus, Rafina, Igoumenitsa, and Volos, and of course for the port of Constanța in Romania and Burgas and Varna in Bulgaria. So for us, it's let's say the knowledge that we are day by day we are working on that. We're getting better, and we extend our knowledge on these systems. And the most important is that we perform these studies, the fit studies for the systems for different type of vessels. Since each type of vessel have different demands, different design, and so on. Regarding, let's say, the solutions, except from the studies, what we can see, there are two major areas where a company can make significant contributions. As we see that all the ports are stepping towards the decarbonization. The first one is the centralized energy management systems. And the second one is the cybersecurity. Regarding the first one, we think that as discussions revolve around the decarbonization of the ports and enhancing energy efficiency, we envision the transforming of a port into an energy hub. So this involves the integration between various production systems, renewable energy sources, battery systems, and so on, and how we can manage high energy consumptions. such as the short-side electricity systems, vessel chargers, and so on. So this type of system is essential for optimizing the operation of these systems. As an example, we have designed a system for the port of Igoumenitsa under the framework of the Alpheon project, which effectively manage the 3 OPS positions and an energy storage system in order to perform the better efficiency of these 2 systems. And the second critical consideration is the cybersecurity of these systems. You can think a scenario where cruise vessels have been supplied with electricity, and let's say we have an intruder hacker that is targeting the system and cause a blackout. You can imagine the consequences. So taking into account our experience with transmission and distribution operator systems, we can enhance the cybersecurity of these systems, providing an additional layer of protection against these potential threats.
Okay, thank you very much. These are really, really important aspects, and it's good that we have companies like Protesys working on this as well, and not just on the parts that are also crucial for the implementation of the systems. So finally, as a final question, I would like to ask you, based on the results of your studies carried out so far, which technical challenges have you identified regarding port decarbonization? And of course, as I understand that the main focus until now has been related to cold ironing, with the focus on that.
Okay, I think for that it's something we are facing again and again, and let's say for the main issue, we can face different type of technical challenges. So as we've covered in the previous questions, there are technologies that are ready for deployment and others that need to further development. However, with the current technologies, there are several challenges to address. And one of the most critical issues that all ports will encounter is the substantial energy demands of this system. For example, we can take as example as the port of Piraeus, the biggest port of Greece, and its passenger terminal. In order to supply 5 vessels, the port needs to provide power that exceeds its existing energy demands by 2 times. Let's say a case study was that the energy demand right now for the port is 10 megawatts, and for 5 positions for the passenger terminal, we need almost 13.5 MVAs. So these raise 2 key points. First, we need to consider how the national grid can handle these increased power requirements, since more and more ports will ask for more power. And it's not working that the national grid operator, HEDNO, is actively working on this matter. And second, the ports themselves must strategize on upgrading their local grids to effectively meet these heightened demands. The grid of the ports was not constructed for such high demands, so we need to think further how we'll upgrade their system. Additionally, there are special challenges for the ports, given that these systems have a significant footprint, and many ports have special limitations within their territories. considering the fact that a lot of ports are inside the urban areas, so have a space limitation. And let's say something more general, it's crucial to emphasize that when we talk about electricity as the green maritime fuel, we must think the energy mix of the power that is produced in order to supply these vessels. And this power production must align with greener practices to meet broader environmental and sustainability goals. Of course, there are a lot of other, let's say, technical challenge issues, but it's more technical. For example, we have issues with special issues with the CMS systems that they have their footprint and there are limitations. For example, in a container terminal, they don't have efficient space for installation of these systems. Of course, each part is focusing on, let's say, the challenges and trying to solve these, and this is continuously developed, and solutions to these challenges are day by day appear, and that makes us very happy.
Okay, I like to complete the interview on a positive note. I appreciate that. What I think is really important here is that when ports were initially designed, of course, all these needs for space and infrastructure were not taken into account, and this is, I think, the extra, the thing that makes it extra difficult to install them, since they are equipment, of course, with it's dangerous. You can't leave it just hanging. It needs also, in terms of cyber security, you mentioned there are a lot of aspects that need to be taken into account. The extra capacity and power and all this create a complex system that has to be of parameters that have to be taken into account. All right, Stefanos, thank you very much for this interview. I don't know if you want to add something, something extra.
No, I'd like to, let's say, admire your effort in the decarbonization of the ports. It's something that we will face and address in the following years, and let's say actions like yours are, let's say, lead to the next step. That I think that the carbon neutrality is something that we need to really consider and taking seriously into account.
Thank you very much. And of course, we will need your expertise and know-how when we're approaching the local authorities and trying to convince them to move forward with actions like that. We will be very, very happy to work with you in that step as well.
Thank
All
you
right.
very much.
Thank you very much. And
thank you.
we'll be in touch.
Thank you.
Goodbye, Stefanos.
Bye bye. Bye bye.